This screencast is about metals, nonmetals, and metalloids. The first thing I want you to do is I want you to take your periodic table and I want you to take your pen, your pencil, or a marker even, and I would like for you to draw on the periodic table. You're going to take it and you're going to go to the left of boron and underneath, and then down and over, down and over, down and over until you get to polonium, and then you're going to go straight downwards in as straight of a line as you possibly can. This right here, a whole bunch of scientists got together in a big room and they looked at this and they tried to name it, and they came up with this super scientific name of the staircase. And the staircase is really important in chemistry because it tells you which side is the metal side and which side is the non-metal side. Taking a closer look at the table, you can see that on your table it tells you to the left, everything that's metal in a box to the left. So on the left, you'll see things that you totally recognize, like nickel or silver or gold, and you know these as metals. You might also see some things that you are not familiar with, maybe tungsten or strontium or cesium. All of these metals have three properties that make them known as metals. The first property that we're going to speak about is the fact that metals are ductile. Ductile means that you can take the metal and you can make a wire out of it. Now, we would want to do this for a couple of reasons, but the majority of the reasons, the main reason why we want to do this, is for electricity. By making these metals into wires, we can conduct electricity. The second property that makes a metal is the fact that it can be hammered into thin sheets. This property is malleability. You take a mallet and you flatten it out. A couple of reasons why we would want a metal to be malleable and why we take advantage of that fact is in making coins. We have art that's been made because metals are malleable, and we also have instruments that have been made because metals are malleable. One of the great reasons that we use malleability is for conduction. We use it in our pots and our pans so that we can conduct heat and we can cook food. The third property that makes a metal is the fact that it has luster. Luster is fancy for the word shine. So as you can tell from all of these samples of metals, metals are shiny. They have luster. By looking at the periodic table, you can tell that most metals actually tend to be solids. A solid is indicated by, as you look back at your periodic table, you can see that most metals are solids. A solid is indicated by a solid square on your periodic table, and you can tell that because it tells you right in the key. The next category that we are going to speak about is nonmetals. And nonmetals are on the opposite side of the periodic table, so nonmetals tend to be all the way to the right. On this side over here, we have all of our nonmetals. An example of a nonmetal would be sulfur. Sulfur is not malleable, it is not ductile, and it does not have a luster. There are some nonmetals that have luster, but sulfur is not one of them. When you look at your periodic table, you can tell that the nonmetals mostly are gases. For that reason, nonmetals tend to have lower densities. They do not conduct electricity, and they do not conduct heat. So the question becomes, if you're not a metal, and you're not a nonmetal, what are you? Well, it's kind of like this. If you're not breakfast, and you're not lunch, what do we call that? We call it brunch. So you have metals on the left side, you have nonmetals on the right side, and in the middle, you don't have brunch, you have something called a metalloid. Metalloids are in the middle of the periodic table, which means they have some properties of the metals. So some of them might be lustrous, Some of them might be malleable, some of them might be ductile, but they don't have all three properties. An example of something that is a metalloid might be silicon. Another example might be arsenic. So to recap, you should have learned that the periodic table is arranged in periods. As you go across the periodic table, that tells you the number of orbitals there are in the elements. The periodic table is also arranged by groups. As you go down the groups, it tells you the number of valence electrons in that column. Groups all have the same properties. The third thing that you should have learned is to the left, everything that's metal in a box to the left. In order to be a metal, the element has to have luster, it has to be malleable, and it needs to be ductile. If it has all three things, it is a metal. Nonmetals are located to the right, and they tend to be more gases, so they have a lower density. And if you're not a metal, and you're not a nonmetal, then you would be a metalloid. A metalloid only has one or two of the metal properties.